Okay, thanks everyone for coming. Welcome to my talk about Spring Boot 1.x overview/intro. My name is Dominik Dorn. I'm a freelance software engineer. I'm also the leader of the Java-Vienna Meetup. Leader means basically the guy that's doing a lot of organization stuff and many talks. Of course, we also have a great team that's helping the Java-Vienna Meetup. To mention Daniel and Mark and Bela that are bringing the beers today and the food. Applause for them. Woohoo! Yeah, yes, right. Yeah, as I said, I'm a freelancer. If you have cool projects in the coming year and need help, please reach out to me. I'm on Xing, I'm on Twitter, I'm on LinkedIn. I'm especially interested in Java and Scala and a lot of other stuff, but let's go to the content. Today's talk will be about Spring Boot. First I will talk a little bit about what is Spring Boot actually, then how you get started with Spring Boot, how you do REST endpoints with Spring Boot, how you test them, and how you can use that in day-to-day work. If you are already working in a Spring Boot project, probably please don't be disappointed, but there will not be much new stuff for you in this talk. If you're working already, maybe in the second talk you will get new information. So yeah. So what is Spring Boot? Spring Boot is basically running a Spring application in an embedded web server. So instead of deploying your application to a JBoss or Oracle server, you are running it as a standalone application. If you're still constrained to one of these environments, you can still export it as a WAR file. What is Spring Boot also? Basically, it's just really complex class path scanning and reflection everywhere. That's why it's probably so slow sometimes. Spring Boot is all about convention over configuration. In Spring Boot, they have a lot of magic that is detecting which database you use. For example, they will detect that you're using Postgres if they find the Postgres JDBC driver in your class path. In Spring Boot 2, they now detect that the Juke dialect, depending on which data sources you have configured and so on. But overall, it's just 99.8 normal Spring application development. So you can use the REST way of creating endpoints. You can use the templating language and also all those things. Yeah, and of course you can also use Spring Security and all the data access helpers like JDBC template and so on. Okay, how you get started with Spring Boot. The common way on how to get started with Spring Boot is either with Maven or Gradle. In this presentation I will focus on Maven because I like it better, more, and it's nice to present. What you usually do in a Maven-based project is you inherit from the Spring Boot starter parent. So what Spring Boot does is they provide many base projects which you just include as a dependency, and in these base projects they include then all the dependencies that you need to run your application. To make a simple web application you just need to extend the Spring Boot starter parent and then include the Spring Boot starter web dependency in your application. Because you're using the parent POM, you don't have to specify any version in your dependencies. Okay, so now we have our Maven project set up. What do we need to do to create a Spring Boot application? The first thing is we need to create a class which has a public static void main method. You know this all from your Java courses, it's nothing special, and the only thing that you do in this method is that you call spring application.run. You supply a class argument. This is the class that is responsible for configuring your application, and you also pass the command line arguments, so you have a way of accessing them later in case you need a hold on them. What you usually do is, in this example, we said, okay, the configuration class for our Spring Boot application is the class we are currently in. That's the MyApp class. And that's also why we need this add configuration annotation on top of it. We then also see that we have the enable auto configuration annotation attached. That means that Spring will try its best to configure the application with the defaults that are specified in the documentation. And we have the component scan annotation, which tells Spring that it should scan the class paths for all beans, services, and so on. If you're tired of typing, you can also do this in a little bit less code. For example, you could just use the annotation at Spring Boot application that's equivalent to the 3 annotations we had before. And you can also use a different configuration class if you prefer to split your main class from the class where you specify your configuration. Yeah. Okay. How do we create REST endpoints? That's quite straightforward. Basically, you just create a class and add the REST controller annotation to it. And for every endpoint that you want to expose in your application, you add a request mapping. For example, we have here the index action of our application, which is basically serving the root level of our application. And we see the request mapping is configured to serve the path /. And if we open this endpoint, we will just serve the string hello Java-Vienna. Okay, that was not really interesting because it's just static content. Of course, there are ways to customize this. There are ways to take user data. One way of doing this is to use path variables. For example, here in this action, we see that we are taking a path variable string who, and then we are modifying our result. Any questions so far? Great. Of course, you can make this a little bit more complicated. We don't want to just access variables in our path, but we also want to access query parameters. You can do this with the add request param annotation. You see here that we named the parameter greeting. You can name it as however you want. Important is that the URL is then called with the name that you specified. And you can also specify default values. By default, our greeting would be hello. And the who is just the name of the person we are greeting. And what you could do is that you just say, okay, you call your application and say, localhost 8080 greet Dominik and then greeting howdy, and it will print howdy Dominik. Yeah, of course, you can also serve different kinds of responses. For this, you have the way to specify what kind of content types your action is supporting in the receiving end and what kind of content types it is supporting when sending out. And if you remember on how a HTTP request looks in the raw format, then you see that there is an accept header in there, and that's basically what Spring uses to match this. So if you have an action like index.json, you can say, okay, this action is only going to be used if the client is requesting JSON. We see here that we can return arbitrary classes in Spring Boot. By default, those classes or those objects actually, they get serialized by checksum. So what we can do here to create a simple JSON object is that we just create a simple hash map, mapping from string to string, and we put two keys and two values, and then we just return that, and Spring will transform this to a JSON object. Yeah, that's how it looks like in Postman. As you see, there's not a lot of magic to it. It's just working more or less. Okay, so we got our controller, how we can test him. Spring also has a starter POM for that. It's the Spring Boot starter test. And how does a test look like? There are basically two ways of writing a test. This is the first way. What you do is first you have to, those are JUnit tests, and first you have to specify that you're running them with the Spring Runner, and then you specify that this is a Spring Boot test, and it's always a good idea to choose it, to configure it to run on a random port. That way in theory you can run them in parallel because they would not interfere with each other. And of course you also have to specify which class is used to configure your application. In this simple case I just used the my app class. If you have a big application, it's useful to specify a different class to basically make the amount of classes used or loaded during the test small, and then it's faster. Okay, what do we have? There's a helper class called test rest template, and with this test rest template you can basically invoke actions in your Spring application. Here we are invoking the action hello Java-Vienna, and we are expecting a return of type string. And down there we are just asserting that the result we received is the one that we expected. Another way to do it is with the Spring MVC. So you can also use Spring MVC, and what you do there is that you inject mock MVC context, and there's another way to basically do the same request. It's just a different way of using a DSL. Yeah, dev workflow. I'm a little bit too fast apparently. To program or to work with Spring Boot, the most comfortable way of working with Spring Boot is if you actually have a JRebel license. Please raise your hand if you know JRebel. Okay, who doesn't know JRebel? Okay, a few were sleeping, but that's okay. Yeah, JRebel is a commercial product. What it does is basically it's proxying the classes in your application with dynamic proxies, and whenever you update, whenever you change a class in your code base and you compile it in, for example, IntelliJ, then JRebel picks up that this class file has changed and reloads it during automatically, and you don't have to restart your application, and you can see the changes immediately. It's very good if you have your own company and you need to get stuff done quite fast. If you get paid by the hour, it's maybe not so good because it's you don't have time to get so much coffee or get a cigarette. And of course, you have to pay for it. That's about $550 per year. If you can't afford that, or your employer isn't paying for that, there are also the Spring Dev tools. The good thing about the Spring Dev tools is that they are free, so you don't have to pay anything for that. They include a live reload plugin. So for Firefox and for Chrome, there's a browser extension which you can use, and this plugin then communicates with that browser extension, and whenever you change like a template or a REST controller, it's making a reload in your browser, and makes so you save about like, I don't know, half a second when switching between IntelliJ and your browser. And yeah, that's quite nice. The contra is that every time you do make a change, it's really restarting the whole application. And I know that there are Spring applications out there that already they have a few hundred classes and they take like 15 to 20 seconds just to start and be ready to serve requests. So depending on the size of your application, depending on how you configured it, this can get really slow. The best thing you can have is if you combine the Spring Dev tools with JRebel, because then you will have this really quick turnaround with class reloading, and you will have the live reload feature in your application. Important when you're using the Spring Dev tools is that you set it optional to true, because you don't want them to be packaged in your production app and be deployed to your customers. Deploying. As I said, Spring Boot, you can start Spring Boot applications basically by just running the main class that you created. The problem is that usually you will have a bunch of dependencies. Most of them get imported by Spring, and if you just upload your jar file to your server, you will be missing those. For that, you have a Spring Boot Maven plugin. And what they will do is that basically they are pulling in all the jar files that you're using in your project, and they create a big fat jar, and you're just uploading this jar file to your application, to your server. Or you can just, if you're on UI, if you have a UI on your server, then you can just do a double click, or you do a Java -jar and start the application. So basically to start your application, it's just jar -jar, and usually it's target and then the name of the artifact. But of course, that's boring, that's old school, no one wants to do that really. That's why we have Docker. And the guys from Spotify, you know that service where they recognize music for you when you're somewhere and you just say, hey, that song is cool. They created a Maven plugin to create Docker images, and basically what you're doing is, the only thing you're doing is basically specify the image name. If you're using the public Docker registry, in my case that would be Dominik, and the name of my artifact. And what you also do is that you specify a custom Docker file where you pull in additional stuff that you might need during runtime. For example, I don't know, maybe you need image magic or something like that in your Docker file, in your container. If you don't need any additional stuff, you just say from OpenJDK, Java 8 and stuff like that, and you'll be done. That's basically all for Docker. Going to production, a really cool thing that Spring is shipping for free is the project Actuator. What they are doing here is, maybe start with what is written on the slide. To include Actuator in your project, just add this starter POM, Spring Boot Starter Actuator. And the cool thing is that Actuator basically gives you a lot of endpoints for monitoring and configuring your application. For example, there is the endpoint audit events, where you see all events require corresponding to security. For example, if someone is trying to hacking you, you will see that there. You can use the endpoint beans to get a list of all the beans that are registered in your application. You can use the config props thing to see, okay, how is my application running at the moment? What are the effective configuration values there? Of course, you can also use the endpoint to see in which environment variables is my application using. You also have endpoints for Flyway and Liquibase, where you can see which migrations got applied. That's especially helpful if you're trying to figure out why the application suddenly stopped working, and because you deployed something new. There's a health endpoint that's usually required if you are using Kubernetes or something like that, because the load balancer is always checking the application for health. A cool endpoint is HTTP trace, where you basically can see the last 100 HTTP requests that were sent to the server, and you can see basically the request headers and the response headers. It's really cool for debugging. Also really cool is the loggers endpoint, where you see the configuration of all the loggers in the application, and you can even change them at runtime. It's really cool. And yeah, we also have metrics like how long did my action take. We have an endpoint for mappings, where you can see all the paths that are registered in the application. We have a scheduled tasks endpoint, where you can see all the Quartz jobs that you have in your application and when they are supposed to run and when was the last time they were running. And you also have a thread dump and a heap dump endpoint, where you can easily download those and analyze them if you're thinking, okay, the application takes too much memory or it's locked somewhere like that. Yeah. There are even more endpoints than I just showed you, and in Spring Boot 1 most of them are enabled. With configuration you can enable and disable them on a per endpoint basis. If you're using Actuator, I highly suggest you do that, because it would be bad if someone else would just figure out what's your Actuator path and then see your environment variables and maybe see the password for your database. So when using Actuator, take care of that. And I'm a little bit too fast, but that's okay. That's for this talk. So thanks for your attention, because at least you were not sleeping, and that's a great thing in this late hour. And yeah, Venkat is a great guy. He will be here next month for the Java-Vienna meetup. So I hope to see you all there. And thanks for the attention. And yeah, reach out to me if you have questions. Ask now, or be silent forever. Thank you. Questions?